All right, here's a few more examples. So we haven't done one where just finding all solutions. So let's just say find all solutions, and we'll say in degrees for this problem. Cosine of theta is equal to sine squared of theta over 2. All right. What do I know? I know that I have a half angle and I have a regular angle. So this is when we do want to use our equation. So sine of theta is equal to that plus or minus square roots 1 minus cosine of theta all over 2. Now, I need this to be squared. So the only way to square it is to actually square the right side and the left side. So if I do that, that means I'm going to be able to replace sine squared of theta plus or minus the radical are going to go away. And I'll be able to replace it with this lovely equation. So I'm going to go ahead and take this guy and replace it for that. So it'll say cosine of theta is equal to 1 minus cosine of theta all over 2. Multiply 2 to both sides. So 2. So 2 cosine of theta is equal to 1 minus cosine of theta. Add cosine, so I get 3 cosine of theta is equal to 1. I'm going to get cosine of theta is equal to 1/3. Well, this also is the first example where 1/3 actually is not on our unit circle. So we have to talk about our inverse. So let's go ahead and do our inverse to this problem. So this will become the inverse of cosine of 1/3 is equal to theta. So let's go ahead, plug it into our calculator. So again, I'm in the degree mode. So I'm going to say inverse of cosine, and don't type it in as 0.3 with a bar over it, because we can't. So I'm going to get 70.5, and let's round to just 1 decimal. So we're going to say theta is about 70.5 degrees for our first problem. And we have to remember that cosine is positive in quadrant 1 and quadrant 4. So this just gives us quadrant 1. So again, let's use our knowledge that if we're 70 degrees-ish about this way, that means if I went this direction, 70 degrees, 0.5, I'll get my second one. So I'm going to do 360 minus the 70.5 degrees. So again, if we need a calculator, so 360 minus 70.5, I will get 289.5 degrees. So theta is also equal to 289.5 degrees. But this problem, it didn't want us to find between certain numbers. We want to find all of our solutions. So this is where the equations are going to come into play. So we're just going to say theta is equal to 70.5 plus 360n, and then theta is equal to 289.5 plus 360n. So we have two equations. We don't have to worry about plugging in anything, and we're done. All right. Let's try a different one. So how about something that looks like this? Same problem, so find all solutions, and we'll say again in degrees for this. So 4 cosine of 2 theta is equal to 8 sine of theta cosine of theta. Ooh, so this one looks a little tricky. Okay, what do I know about this problem? I know that there's a sine and cosine being multiplied together. So if I break this apart and say that this is really 4 times 2 sine of theta cosine of theta, now all of a sudden I have 4 cosine, a double angle of cosine, is equal to the 4 times the sine of the double angle. Okay, they both have 4 on both sides. I can cross them off. So I basically want to know, when will the cosine and the sine be the same? Again, I could write a let statement, so let's let 2 theta equal x. So if I do that, I'm going to get cosine of x is equal to sine of x. Where are they both going to be the same answer? Well, they're both going to be positive in the first quadrant, so it needs to be quadrant 1. They're both negative in quadrant 3, so we're looking at quadrant 3. And where's the only numbers that will ever give you the same values? It's when it's a root 2 and a root 2, so either positive or negative. So that means, again, I said it in degrees. We're talking about 45 degrees, and we're talking about 225 degrees. But those aren't our answers. That's just to make x be the same. So when I come up with my equations, I'm going to say 2 theta is equal to 45 plus 360n. I'll divide by 2 to everything. So half of 45 is 22.5, and then half of 360 is 180. And then I'll do the same thing with the 225. So divide everything by 2. So theta is 102.5, I believe. Check my math. And that's it. Those are our 2 answers. So one here and one here. Now, is there more than one way to solve this problem? Absolutely. All right. I'm just looking for the one that's the easiest to see. All right, let's try another one. So why don't you guys pause the video and try this problem. So this will be number 9. So solve, and let's go back to radians, 0 to 2 pi, and solve it for this one. Sine of 3x cosine of x, cosine of 3x sine of x is equal to 0. So go ahead, pause the video, and see what you come up with. All right, if we're coming back from paused video, hopefully what you notice is that sine of 3x, cosine of 3x, this is like your a value, and cosine of x and sine of x is like your b value. So this is the same as saying sine of 3x plus x is equal to 0. So again, we're using that sum and differences from our previous chapters. So this is really sine of 4x is equal to 0. All right, so let's write a quick little let statement. Let theta equal 4x. So we have sine of theta is equal to 0. There are 2 answers that theta could possibly be, 0 and pi. So I'm going to have my first equation. I'm going to say 4x is equal to 0 plus 2 pi n. So x is equal to 0 plus pi n over 2, because the 4 and the 2 simplify. And then my second equation, so 4x is equal to pi plus 2 pi n. And then I'm going to leave this all with the denominator of 4 for this problem. All right, so what happens when I say n is equal to 0? Let's do it in red. I'm going to get 0. And over here, I'm going to get pi over 4. When n is equal to 1, 0 plus, and then this will just be pi over 2. And then when I plug a 1 in, 2 plus 1, so this will become 3 pi over 4. All right, let's continue. Lost my equation. N is equal to 2. So if I plug this in, 2 over 2 is just going to be pi. If I say this one, 2 times 2 is 4. 4 plus 1 should give me 5 pi over 4. N is equal to 3. So this will just become 3 pi over 2. And then 2 times 3, 6. 6 plus 1 gives me 7 pi over 4. If I try to go to n is equal to 4, this is not going to work because 4 times pi will leave me with 4 pi over 2, which is the same thing as 2 pi. So too big, which means that this guy is definitely going to be too big. So this will be at 9 pi over 4. So again, too big. So our answer, x is equal to, you should have gotten 0, pi over 4, pi over 2, 3 pi over 4, pi 5 pi over 4, 3 pi over 2, and 7 pi over 4. We should have had 8 numbers. 1, 2, 3, 4, 5, 6, 7, 8, because notice that we had a 4 in our problem. Right? It wasn't in our original problem, but it was still in our problem. All right, last example. All right, so last example, let's solve it with degrees. So 0 degrees to 360. Here we go. Go ahead, pause the video, try this one out. Cosine of 4x, cosine of x, plus sine of 4x, sine of x is equal to 1. All right, so if you're coming back from the pause video, hopefully you recognize that this was the sum and difference for cosine. So this would become cosine of 4x minus x. Remember, you change that sign, and that's equal to 1. So cosine of 3x is equal to 1. Again, let statement, let theta equal 3x. Cosine of theta is equal to 1. We have only one choice. Theta has to equal 0 degrees. So I'm going to go ahead, I'm going to say 3x is equal to 0 degrees plus 360n. Divide everything by 3. So x is equal to 0 degrees plus 120n. So when I plug in for when n is equal to 0, I'm going to get x is equal to 0. When I plug in 1, I'm going to get x is equal to 120. When I plug in 2, I will get x is equal to 240. When I plug in 3, I will get 360. But that is outside my domain. So my answers are x is equal to, bam, 0 degrees, 120, and 240. Now this one's a little bit different. Notice that this time we actually had a 3 in front of the x, but we only had 3 numbers. This one is because we only had one equation. So basically our equation always kind of dictates how many numbers we're going to have. So if this ended up giving us with 2 equations, we would have had 6, right? But it only gave us 3 equations, or sorry, 1 equation, which means we only had 3 answers. Okay, if you want additional problems, I'm going to put 3 more up onto a new part, but it is not mandatory to watch.